Hello. In this tutorial, we're going to build on a tutorial that we previously completed where we modeled a three-span girder subjected to dead load in SAP 2000. And in this tutorial, we're going to expand on that to include a truckload in each of the three spans, to add hinges to the girder, and to add cover plates to reinforce the girder over the interior supports. Let's get started. Okay, so here's the model that we created in the previous tutorial. The first thing I'm going to do is save it as a new file. Don't want to overwrite any earlier work that I did, so we'll start with a new file name in case something goes wrong. We need to go back and work with the earlier edition of it. So the second step of the process is to divide the frames up. We need to have a node everywhere where the cross section changes, and we need to have a node wherever there's a hinge or a pin in the model. So we'll go ahead and select that first element like that. We'll go up here to the edit menu and then go to edit lines and then divide frames. And this lets us take frame objects or line objects in SAP and divide them into two objects. So there's a number of different ways of doing this. We want to divide the frame at a specified distance from the ith end of the member, and I'm going to use absolute distances, and for the span AB I want that division to come at x equals 52.5 feet. So I hit apply and then hit OK. We go back to the main window and you can see that a new node has been placed there. I'm going to take just a second here and show the restraints in the model so that I could see where I'm at relative to the supports. Graphics are a little bit slow on this computer, particularly when I'm recording video. That takes a lot of graphics work. All right, let me go ahead and do span BC, and I need 1, 2, 3, 4 nodes added. So this needs to go from one member into 5. In visual analysis, we were able to do that with one sequence of menu picks, but here we have to do 4 different versions. We have to split it 4 times. So in order to keep the values, the X location of the splits manageable, I'm going to work from right to left instead of left to right. So I select that element, go to edit lines, divide frames, and the one that I want all the way to the right is going to be an absolute distance of 67.5 feet. So I do that, I hit apply, and then I can move that window over a little bit. Maybe I'll move it up there like such. Then I can come back and select that element again. The next one that I want is at 60 feet. So if I weren't working from right to left in this element, I would have to measure that distance from a different point each time, and that's why I've done this. So this one is going to be 15 feet, and then the last one will be 7.5 feet. Hit apply. And then finally I select span CD. It's already set for 7.5 feet, so I can hit OK. And there we go. We have all of the frames divided the way that we want. All right, now the next task is to redefine the cross-section for the members over the interior supports to include the cover plates. So I'll do that next. I'll go ahead and drag a window here, hold down the shift key, drag a window there, and I get those 4 elements, 4 line objects selected. So I'll go to assign frame sections, and I want to define a cross section that has the cover plates, but it's not listed here. I haven't defined it yet. So I need to go to define sections. I'm going to add a new property, and I'm going to use a general section here. We can use section designer. I'll come back at the end of this tutorial and show you how to do that. But for right now, let's just define it as a general section where we input the section properties manually. So 89.69, 23,070, And this one's going to be 1450. And really the only one we need, since this is a problem that's dominated by flexure, is the moment of inertia. The rest of them are all fairly well moot, but just for sake of completeness, I'll go ahead and put them in anyways. And then 28.7 is actually the torsional constant of just a W36 by 231. It doesn't include the cover plates at all. All right, so I get those values in. I have made an error though. I'm going to have to back up and do this again. I'm in units of kip and feet, and so that means that my values that I entered here are going to be 23,070 feet to the fourth. So I don't want that. It won't let me change the units, but I wonder if I could do this. Go inches squared. Nope, won't let me do that. All right, let me cancel out. Go back here, cancel that. Still won't let me change that, cancel that. There we go. Now I can go to inch units, go back and do that again. Define, add new property, other, general. There we go. Okay. Apologies. But maybe you'll learn more from watching me have a mistake than by watching me do it right every time. 27.74. 52.78, 28.7, and then these will all be unit values. Okay, hit OK. This we'll call W36X231 W cover plate. Okay, like that. We could set our material properties here, but they're fine. Property modifiers, time-dependent properties, that all looks fine to me. Hit OK. Hit OK again. Then down here we select that, and this is where we actually assign that property to those line objects. Then hit OK. All right, I'll zoom in a little bit. Yep, looks good. Okay, looks fine. All right, so next step then is going to be for us to define the hinge location. So I'll select this center member. I'm going to put a hinge at the left and the right of that member. And so we go here to assign, frame, releases, and partial fixity. Now be careful, down lower in this menu is something called hinges. And the first couple of times through here, you might be inclined to define a hinge, but a hinge is something different in SAP 2000. It's actually like a plastic hinge that you would use for an earthquake analysis. So we don't want that. We want a release instead of a hinge. So we go to this menu, and it lets us use a checkbox to define full release. So I'll release the major axis moment, M33, at both ends. Okay, if we wanted to, we could put in a spring support by putting in a spring constant here, stiffness. So I hit apply, and there we go. Graphics is slow, like I said. And those green dots represent the hinges at the end of that member. Okay. The joint restraints that we have set up are good. We don't need to modify those at all, so let's move on to our loading. So we'll look at load patterns first, define load patterns. All that we have right now are dead loads. I want to define live loads for span 1, span 2, span 3. So to define a new load pattern, we go in here, type the load pattern name, and we give it a type, and then we hit add new load pattern. Oops, I'll call it live 1. Do the same thing for live 2, add new load pattern. Do the same thing for live 3, add new load pattern. Okay, looks good. We'll hit OK. All right, then the next step is to make sure that we assign the loads to the actual members. So I'll go here to the center member. I'll go to assign, frame loads, and then point. Now, one advantage that SAP 2000 has over visual analysis is that we can define multiple point loads in the same dialog box. So I'll set this as live 1. Remember, pattern number 1 is with the truck in span 2. So I'm going to use absolute distances. And so in this case, I would want a distance. Let's see, that member is 45 feet long. It's 15 feet off each end. It was originally 75. So minus 30 gives me 45. So 45 divided by 2 is 22.5, and I want to go minus 14 feet from there. Got to watch units though. So let's see if I go to feet here. Yep. All right, so you converted the number for me. So let me start over again. 22.5 minus 14 gives me 8. This is going to be 22.5. This is going to be 22.5 plus 14. Now here I want 32 kips times impact times 0.9643. Now there's no negative number there to indicate that it's down. It's in the gravity direction, and the gravity direction by default is already in the negative z direction. So I can leave that as is. Then here I can go 32 times 1.33 times 0.9643. And for the front axle, I go 8 times 1.33 times 0.9643. Like that. Hit apply. And the loads pop up. Okay, now over here, I'll select this member, go to live pattern number 2. My distances change here. So half of 60 is 30, so 30 minus 14. This is going to be 30. This is going to be 30 plus 14. Okay, and I hit apply for that. Now that gives me a different load pattern. And then finally up here, this is going to be live 3. So this was going to be 30, but I dropped 7.5 feet from the first end, then I dropped 14 from that. Let's see, this is going to be 8.5 plus 14. That's going to be 22.5 plus 14, 36.5. Hit apply. And loads pop up correctly. Good. Okay, we'll close out that window. So that defines our loads. Now I'm going to check the load cases. Remember, the load cases tell us what to do with the loads. So we have 3 linear static load cases created for each of the new live load patterns. So let me go ahead and modify that just to see what's in here. Now when I do bridge analysis, a lot of times I'll put the girder distribution factor in here instead of in the other place. And that works out to be a little bit more convenient, but for sake of consistency with our visual analysis model, we'll leave it as 1 here, and we'll leave the distribution factor in the actual definition of the loads. So I'll cancel out of that. This all looks good. So I just hit OK and cancel out of that. All right, now we're going to do some load combinations now. So we go to define load combinations like that. I'm going to add 3 combinations to represent the AASHTO strength 1, and then 1 fourth combination to give me an envelope. So let's go ahead here and do, we'll call it AASHTO strength 1 like this. And it's going to be a scale factor of 1.25 times the dead load plus live load 1 at a factor of 1.75. Okay, we have a linear add for our options, so that's pretty good. That looks right. We'll add a new one. We'll call it AASHTO strength 1, whoops, pattern 2. So in this case, we'll do dead times 1.25, do live 2 times 1.75, and we're good. This time I'll add the third one. I'll say add a copy of that combination. So type in the name AASHTO strength 1 load pattern 3. So it gave me a copy of load combination 2. So I need to change that to live 3, and then I hit the modify button here. That looks good. And then I'll create a fourth combination, which is an envelope. So I'll just call that envelope for lack of a more creative. And I want strength 1, pattern 1 combination at a scale factor of 1, strength 1, load pattern 2 at a scale factor of 1, and AASHTO strength 1, load pattern 3 at a scale factor of 1. And up here for the load combination type, I want envelope, like such. Okay, that looks good. I have 4 combinations, so click OK, and we'll back out of that. All right, I think we're good to go. Let me go ahead and run the analysis, run all these patterns, and then the next step is we get the deformed shape of the model. and I can start defining or examining my moment and shear output. So M33 is a strong axis moment. So here is the bending moment diagram. It comes up inverted at first, drawn for the tension side. So I have to hit this button twice now in order to get it to show right. There we go. All right, and then if we want to, we can go back to this window and show values instead, and that gives us an annotated diagram. All right. Okay, and so now I can also select the envelope value here as well. And you can see that for the envelope value, I get maxima and minima at each of those locations. All right. Another option that SAP2000 has for defining section properties is called the section designer. And this is basically a primitive CAD package that lets you draw shapes in the to be used as cross sections, and then SAP will calculate the section properties for you. So I'll select those four members that represent the area of the girder that are going to have cover plates, and then I go to assign frame sections, and then in this case I'll click define section properties again, and I'll add a new property and then use section designer. Now, one thing to bear in mind is I have my units down here in the lower right hand corner set in inch units, not feet units. So in this case, I'll select my base material is going to be steel. So I'll say A992 grade 50. Then I'll go into section designer, and that launches a different window like this. Now we also have the option of defining units here in the section designer as well. Right. So what I'll do is I'll start off with the primitive shape. It's not a primitive shape. The rolled shape, the W36 by 231, and I have the option of inserting that up here by just going to insert I section, and I'll click at the origin. So that gives me a default I section with default properties. I need to modify those. So it gives me the height, that's 36.5 inches. The width of the top flange is going to be 16.5 inches. The width of the bottom flange is going to be 16.5 inches. The thickness of the top flange is 1.26. The thickness of the bottom flange is 1.26. And the thickness of the web is 0.76 inches. I think that's it. So I'll go ahead and hit OK. And that gives me that cross section. Okay, at this point, we'll go ahead and add the cover plates. So I click here to draw a shape, and you can select different kinds of primitive shapes, rectangles, circles, etc. So the cover plate's going to be up here. I'll just position it approximately, and it just gives me a square. And so if I right click on that, then I can go in and adjust properties. I want the X to be centered at 0. I want the height to be 5/16 or 0.625, and I want the width to be 15. For the Y center, I need to take half the depth of the 36 by 231, so 18.25, and then half the thickness, so 5/16. So that gives me 18.56 inches. Now, one thing to be careful of is that the material by default comes out as concrete. So we want to make sure we change that. Otherwise, it uses a modulus elasticity of concrete in calculating section properties. So this could be useful in defining composite beam properties, for example, but we don't want that in this case. So we hit OK, and that gives us the top cover plate. I'll do the same thing for the bottom cover plate. Just sketch it in there, right click. So let's see, the height is going to be 11/16, 0.6875. The width is going to be 18, and the Y center is going to be half the depth plus half the thickness, so minus 18.59. So you'll note that SAP Section Designer is a little bit more primitive than SAP itself in that you can't do calculations in these windows. So that's a little bit frustrating when you're used to being able to just do primitive calculations in those windows. So, all right, now hit OK, and let's see what it looks like. It looks pretty good. Let's zoom extents. There we go. Looks right. Let's display our section properties. And so we have I33 of 22,839. I had calculated, I think, what, 24. Let's see, I had calculated 23,070. So that's not too far off. This definition here in Section Designer does not have the fillets that make up the transition in the K area of the rolled section. So that might contribute a little bit to that difference. The area is 89.05, whereas I had calculated 89.96. So a little bit different, but if you have complex shapes and you don't feel like calculating section properties, then this can be handy. There's also additional options in here where you can define a fiber model so that you can look at nonlinear material behaviors. And that's useful if you're dealing with concrete or reinforced concrete or composite steel and concrete members. So let's go ahead and click OK here, and then File, Exit, and return to the main program. And we'll call this W36X231 with cover plates, and I'll just put SD to indicate Section Designer, and hit OK. And then we can hit OK here and then select that as our members. And if we go in and right click on those members, then it gives us that, and we can click there. We can modify or show that property, and then it gives us these properties here. So, all right, so quick tutorial on how to use Section Designer. I'm certainly not an expert in using that. I don't use it very much, but it can be very useful, so I wanted to make sure you guys were aware that it is an option. All right, hope this was helpful.